Hi friends, how are you? Welcome back to fourth session of alcohols, phenols and ethers. In this session, we discuss about the preparation of alcohol. See here, there is a first method from alkyl halide. Okay, in this alkyl halide, hydrolysis of alkyl halide by aqueous alkali like NaOH or KOH. And the second method, it is the hydrolysis of alkyl halide by moist silver oxide. First of all, we discuss about the hydrolysis of alkyl halide by aqueous alkali like NaOH or KOH. See here, when alkyl halide is heated with aqueous NaOH, then it gives alcohol, and byproduct is NaX, that is sodium halide. For example, C2H5Br ethyl bromide is heated with aqueous NaOH, then it gives C2H5OH, that is ethyl alcohol, and NaBr, sodium bromide. Then we discuss about the second method, that is hydrolysis of alkyl halide by moist silver oxide. By moist silver oxide. Moist silver oxide, that is Ag2O. See here, moist silver oxide, that means Ag2O, it is treated with water and it gives silver hydroxide. Then this silver hydroxide is heated with alkyl halide in this way. Then it gives alcohol and AgX, silver halide. This is the alcohol and silver halide. For example, C2H5OI, that is ethyl iodide, is heated with moist silver oxide, then it gives C2H5OH, that is ethyl alcohol and silver iodide. Okay. Next example, it is isopropyl bromide. Second example is, this is the first example. Then second example, that is isopropyl bromide, CS3C HCS3Br, that is isopropyl bromide. This isopropyl bromide is heated with moist silver oxide, then it gives CS3 CH CS3OH and AEBr, and the name of this compound is isopropyl alcohol. Isopropyl alcohol. Okay, these are the two examples of hydrolysis of alkyl halide by moist silver oxide. Then second preparation, that is hydration of alkene by using concentrated H2SO4 sulfuric acid. See here, general reaction RCH double bond CH2, that is alkene. This alkene is treated with concentrated H2SO4. This concentrated H2SO4 we can write in this way: HOSO3H, concentrated H2SO4. Then it gives alkyl hydrogen sulfate. Then alkyl hydrogen sulfate is treated with water. Then it gives RCHOH CS3, that is alcohol, and H2SO4, that is sulfuric acid, is regenerated. See the examples of hydration of alkenes. First, CH2 double bond CH2, that is ethene or ethylene, is treated with concentrated sulfuric acid. Then it gives CH3 CH2O SO3H, that is ethyl hydrogen sulfate. Then ethyl hydrogen sulfate is treated with water. Then it gives CH3CH2OH and H2SO4. This CH3CH2OH, it is ethyl alcohol. Ethyl alcohol. This is the symmetrical alkene. This is the example of symmetrical alkene. In this symmetrical alkene, there is no problem of formation of alcohol. But in case of unsymmetrical alkene, it is not directly form the alcohol. For this, we can see one of the example, CH3 CH double bond CH2. This is the propene. This is the example of unsymmetrical alkene. Okay. In this unsymmetrical alkene, propene reacts with concentrated sulfuric acid. This concentrated sulfuric acid reacts with propene according to Markovnikov's rule. What is Markovnikov's rule? We have already studied in the 11th class. Markovnikov's rule is that rule in which unsymmetrical reagent gets added to the unsymmetrical alkene, then this negative part gets attached to that carbon atom of carbon-carbon double bond, which carries the lesser number of hydrogen atoms. See here, this carbon atom, there is only one hydrogen atom, and this carbon atom, there is two hydrogen atoms. Hence, this negative part gets attached to this carbon atom, and it gives CH3 CH OSO3H, and another, this positive part gets attached to this another carbon atom, and it gives, that is, isopropyl hydrogen sulfate. Isopropyl hydrogen sulfate. Then this isopropyl hydrogen sulfate is reacts with water, then it gives CH3 CHOH CH3 and H2SO4, and this product is called as isopropyl alcohol. Isopropyl alcohol. This is the second example of hydration of alkene. This is symmetrical example of symmetrical alkene, and this is unsymmetrical alkene. Okay. Then we discuss about the mechanism of acid catalyzed hydration of alkene. Okay, it involves this mechanism. It involves the following three steps. Number one, step first, formation of carbocation intermediate. Okay, see here, this water is treated with proton and it gives the hydronium ion. Then this hydronium ion, it reacts with alkene. Okay, and it gives the carbocation. Okay, from this hydronium ion, one hydrogen atom attached to the one of the carbon atom, and it gives the carbocation, and remaining portion is HOH, that is the water. Okay, in the second step, nucleophilic attack of water on carbocation. This water again attack on this carbocation. Okay, in this way, see here, this double bond attack on this carbocation, and it gives the intermediate. Okay, in the step third, from this intermediate, hydrogen atom is removed by this water, okay, and it gives an alcohol, okay, and hydronium ion. This is the mechanism of acid catalyzed hydration of alkene, okay. Then next preparation, hydroporation, that is oxidation of alkenes. In this reaction, alkene reacts with diborane, then it gives the trialkyl borane, okay, which on oxidation with hydrogen peroxide in presence of alkaline medium, then it gives the alcohol, okay. For this we can see, we see the one of the example, propene, okay. See here, this is the propene. Then propene, it reacts with diborane, then it gives the tripropyl borane, okay. Then this tripropyl borane is oxidized by hydrogen peroxide in presence of alkaline medium, then it gives the propane 1-ol. It is also called as N-propyl alcohol, and this product is formed by anti-Markovnikov's rule, okay. We have already seen the last preparation, that is the Markovnikov's rule, okay, and this is the anti-Markovnikov's rule. It is opposite of Markovnikov's rule, okay. Then next preparation, by reduction of carbonyl compounds. As you know, carbonyl compounds, that compounds in which C double bond O group is present, that is the functional group. For example, aldehydes and ketones, aldehyde, ketones, carboxylic acids. These compounds contain the carbonyl C double bond O group, okay. Hence, it is called carbonyl compounds. Then, in which first preparation by reduction of aldehydes and ketones. This aldehydes and ketones, okay, aldehydes and ketones on reduction it gives the alcohol. This aldehydes on reduction it gives the primary alcohol, okay, and then ketones on reduction it gives the secondary alcohol, okay. First, reduction by catalytic hydrogenation. There are the two methods for the reduction of aldehydes and ketones. One is the catalytic hydrogenation, and another method it included in your syllabus, that is the lithium aluminium hydride. Okay. First of all, we discuss about reduction by catalytic hydrogenation. This see here aldehydes. RCHO, that is called the aldehyde. Aldehydes reacts with hydrogen gas in presence of Raney nickel or platinum or palladium also. Then it gives the primary alcohol RCH2OH. For example, acetaldehyde CH3CHO. Acetaldehyde reacts with hydrogen gas in presence of Raney nickel, then it gives ethyl alcohol, okay. Then ketone reacts with hydrogen gas in presence of Raney nickel, then it gives the secondary alcohol. For example, acetone, this is the example of ketone. It reacts with hydrogen gas in presence of Raney nickel, then it gives the isopropyl alcohol. Then second method, reduction by lithium aluminium hydride. In this method, see, aldehydes on reduction with lithium aluminium hydride and hydronium ion, it gives the primary alcohol. Same ketone, it also reduced by lithium aluminium hydride and hydronium ion, and it gives the secondary alcohol. For example, see here, paint 3EnAl, okay, paint 3EnAl. See here, 1 2 3 4 5. 5 means paint. 3, there is a double bond, and 3 En, and first position it is Al, okay, there is aldehyde group, hence Al, paint 3 3EnAl. Then this pent 3EnAl on reduction with lithium aluminum hydride and hydronium ion, it gives pent 3En1all. See here. First, second, third, fourth, and fifth. 5, that is the pent on third position, double bond, hence 3En and 1 all. Okay. This product in this reduction of lithium aluminum hydride, this lithium aluminum hydride does not reduce the double bond, okay. And in case of catalytic hydrogenation, this pent 3EnAl, it reduces this double bond and it gives the product in this way. See here, CH3, CH double bond, CH, CH2, CH4. On catalytic hydrogenation, nickel catalyst, it gives the product CH3, CH2, 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 CH2OH. Okay, that is the pentanol. This is the difference between these two methods. This lithium aluminum hydride, it gives the pent 3En1all, and this catalytic hydrogenation, it gives the product pentanol. This is the basic difference between these two methods. Okay, that means this lithium aluminum hydride, it is used for the unsaturated compounds of aldehydes and ketones. Okay, and this this catalytic hydrogenation, it is generally used for the saturated compounds. Okay. Then second, reduction of carboxylic acid. Okay, we have seen in the before, that is the aldehydes and ketones, and then we discuss about the reduction of carboxylic acid. See here, this carboxylic acid on reduction with strong reducing agent like lithium aluminum hydride, then it gives the primary alcohol. Okay. For example, acetic acid, this is the example of carboxylic acid. This acetic acid on reduction with lithium aluminum hydride and hydronium ion, it gives the ethyl alcohol. See here, CH3, this C double bond O group, it is converted into CH2 group. This C double bond O, it is converted into CH2 group. Okay. Then it gives CH3 CH2OH. Okay. Then ester, it is also carbonyl compound. Okay, and this carbonyl compound ester on reduction with lithium aluminum hydride and hydronium ion, it gives a mixture of alcohol. See here, this R C double bond O, this R C double bond O and O. Sorry, this R C double bond O, it gives the RCH2OH, and this RO, it gives the ROH. See here the example, methyl acetate, CH3 C double bond OCH3, that is methyl acetate on reduction with lithium aluminum hydride and hydronium ion, it gives ethyl alcohol CH3 CH2OH, and another is CH3OH, that is methyl alcohol. Next example, CH3 C double bond O O3 2H5, that is ethyl acetate. This ethyl acetate on reduction with lithium aluminum hydride and hydronium ion, it gives ethyl alcohol, and another also ethyl alcohol. It gives the two molecules of ethyl alcohol. Then next preparation by addition of Grignard reagent. As you know, Grignard reagent, it is the alkyl magnesium halide, RMgX. Okay, see here, first preparation of primary alcohol. This primary alcohol is prepared from formaldehyde. Okay, this is the example of aldehyde. This formaldehyde, it reacts with Grignard reagent RMDX in presence of dry ether. Then it gives a magnesium complex. See here how it is prepared. See, there is carbon and oxygen, there is double bond. From this double bond, one of the bond, it is shifted towards this oxygen atom and it acquires partial negative charge, and this carbon atom, it acquires partial positive charge. Why? Because there is electronegativity difference between carbon and oxygen. Okay, this carbon, it is more electronegative atom and carbon is less electronegative atom. Hence oxygen atom acquires partial negative charge and carbon atom acquires partial positive charge. See, RMDX, it dissolves and it gives R negative part and this MDX, it is the positive part. Then this alkyl group gets attached to this carbon atom. See here. Then MgX gets attached to this oxygen atom. See here. And it gives the magnesium complex. This magnesium complex is hydrolyzed by mineral acid like dilute HCl. Then it gives primary alcohol. See here how it is prepared. From this, it dissociates and it gives the negative ion and MgX is the positive ion, in which H positive and OH negative obtained by dissolution. Okay, and this hydrogen H positive ion gets attached to this oxygen atom and it gives this CrCH2OH, that is primary alcohol, and this OH hydroxyl ion gets attached to this magnesium and it gives MgOHX. Okay, then we see the one of the example of preparation of alcohol. For this formaldehyde, it reacts with Grignard reagent, that is methyl magnesium bromide. This is the methyl magnesium bromide. Magnesium bromide. What will happen? This formaldehyde reacts with methyl magnesium bromide in presence of dry ether. Then it gives magnesium complex in this way. Okay. Then this magnesium complex hydrolyzed by dilute HCl and it gives a compound, that is CH3CH2OH, that is ethyl alcohol. Ethyl alcohol, and this is the byproduct. Okay. Then second, preparation of secondary alcohol. This secondary alcohol, it is prepared by acetaldehyde. Okay, this C, acetaldehyde reacts with Grignard reagent in presence of dry ether. Then it gives the magnesium complex. This magnesium complex, it is also prepared by this mechanism. We have already seen before reaction. Okay, see, there is a C double bond. There are two double bonds. This from this one of the bond shifted towards this oxygen atom and it acquires partial negative charge and carbon atom acquires partial positive charge. Then this Grignard reagent it dissociates and it gives the R negative and MgX positive. This R negative gets attached to this carbon atom, see here, and MgX gets attached to this oxygen atom, okay, and it gives the magnesium complex. Then this magnesium complex or addition product hydrolyzed by dilute HCl, then it gives secondary alcohol. See here, this addition product or magnesium complex it dissociates in this way, O negative and MgX positive. See here, water also dissociates and it gives H positive and OH negative. Okay, this H positive gets attached to this oxygen atom. See here, and MgX positive, OH attached to the MgX positive, and it gives the this side product. And CH3 CHROH, that is the secondary alcohol. Okay. Then we discuss about the example. See here, CH3MgI, and that is the example of Grignard reagent, methyl magnesium iodide. This methyl magnesium iodide reacts with acetaldehyde and it gives in this way, that is the magnesium complex. Then this magnesium complex hydrolyzed by dilute HCl and it gives secondary alcohol. It is called as isopropyl alcohol. Isopropyl alcohol and MgOHI, that is the side product or byproduct. Okay. Then preparation of tertiary alcohol. In this preparation of tertiary alcohol is prepared by ketone. Okay, this ketone reacts with Grignard reagent in presence of dry ether. Then it gives the magnesium complex. Mechanism is same. Okay, see here, C double bond O from C double bond O group. One of the bonds shifted towards this oxygen atom, and it acquires partial negative charge. Carbon atom acquires partial positive charge. Then this Grignard reagent it dissociates and it gives the R negative and MgX positive. Okay, R negative gets attached to this carbon atom and it gives CRRR that is MgX gets attached to this oxygen atom and it gives the magnesium complex. Then this magnesium complex hydrolyzed by dilute HCl and it gives tertiary alcohol. See here, this magnesium complex dissociates in this way. Okay, O negative and MgX positive. Then water also dissociates H positive and OH negative. H positive ion gets attached to this oxygen atom and it gives the tertiary alcohol. Okay, and OH negative ion gets attached to this magnesium positive and it gives the byproduct. Okay, for example, see here, acetone. This is the acetone. Reacts with methyl magnesium bromide. This is the example of Grignard reagent, methyl magnesium bromide. In presence of dry ether, then it gives a magnesium complex CS3, 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 COMgX. Okay. Then, sorry, there is bromide. Then this magnesium complex CS3, 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 OMeBr hydrolyzed by dilute HCl, and it gives a product that is CH3, CS3, CS3OH, and the name of this compound is tertiary butyl alcohol. Tertiary butyl alcohol and byproduct MgOH Br. Okay. In this way, preparation of alcohol is completed.